Okay, in this presentation what I hope to do is show you how I was able to redistribute one set of data, apply an algorithm which then allowed me to create a bell-shaped graph, and was also to split up, and I use this to show the importance of portions, fruit and veg portions, with regards to health and well-being. What we can see on the raw data that originally came in is that we had a mean number of portions of 5.2, and we also knew that it was reported that 52% of children ate more than 5 portions a day, and they also said that 28% of children ate 7 or more portions a day. And I've got a little illustration of how you calculate the mean frequency, which is where you look at the portions. Now when I've said none, I've said between none and 1 is a half, and between 1 and 2 is 1.5. And so I've got this, so there were 4 children that had less than 1 portion, or 4% of children, and so we times that by half, and then the next value was 8 times 1.5, and then 10 times 2.5, and we add those figures together, and then if we divide by 100, because we have 100%, and we end up with a mean frequency of 5.26. Now of course the reported was 5.21, because we're dealing with whole percentages. Of course the real numbers would have been 12.5% or 10.6%, those kind of values. So I'm limited on the decimal accuracy, but it's good enough. Okay, and all of this came from the What About Youth survey. And we'll look at the next slide. Okay, so the other interesting thing, so on the What About Youth survey, it's a self-reported data. They asked children, what did you eat yesterday? How many portions did you eat? There was also another survey going on at the time called the National Diet and Nutrition Survey, and that looked at a wider age group from 11 to 18, and they actually studied over a course of a month or so, and rolling it on for a few years, of what children of that age group actually ate. And what they were able to report back was that only 8%, not the 52 as reported earlier, but only 8% of children ate 5 or more portions. And we can see how these compare. Okay. So, although I had some values from the National Diet and Nutrition Survey, although I had some values which was 2.8 portions were eaten a day as average by the population, and 8% met the 5 a day recommendation. And we know that distributions have what's called a bell type curve, so I was able to try and calculate. I had 92% of people which I had to spread out into more in the middle and less at the ends, and I also knew that 8% was at the tail end, and that was also in a sloping pattern, so I went for a 5-3-1 pattern. Okay. And when I calculate that using the technique that I spoke on the other page, so 8 times a half, 25 times 1.5, 27 times 2.5. When I take all those numbers, I end up with a mean frequency value of 2.8, which was the 2.8 I was looking for. So the question is, I now have 2 sets of data. I have the original set of data from the What About Youth study. Now this is important because they did lots of other interesting questions, and so what I want is the results of those questions, but to be applied to how much fruits and veg they actually ate, not what people felt that they ate. If you don't quite know how big a portion is, then you can misrepresent. And people tend to also try and not exaggerate. They try to feel better about what they bias their answers. Okay, so we're trying to remove the natural bias. Okay. So this is what I mean about the interesting data. They broke it down and they looked at self-reported health of people having excellent health or good health or fair and poor, and they were able to break that down. But what we already know is the percentages of what people ate doesn't make sense when people are actually analysed to what they actually ate. People report a biased value. And so my first thing was to do a very crude translation, which just shifted from the 5.21 mean value down to the 2.8 value. And the difference between that is that I take 2.4 off. And so I'm going to just start, and I'm going to take 2.4 mean value of all the reported healths. And so what I find out is the excellent health, the reported health there was 3.47, and the good health was 2.7. Fair health was 1.8 portions, and poor health was 1.5 portions. Okay. And so I'm going to use that value, and then I'm going to work out the difference between these two values, and then I can apply that difference and actually shift not just the mean values now, but the actual portion rate values that they had. And so what you can see here is that everything's shifted down. Now, I've got what I want is my target means, but if I actually calculate those new shifted values out, they're not quite right. We'll have to work out how we can make them right now. So let's have a look at what we actually calculate for mean frequencies with these new shifting values. And what we can see is that the excellent health, the self-reported mean value there is a bit lower than my target. I can see that good health is near enough the same, marginally higher. But I can see the fair health, the mean number of portions, is getting larger now than my target. And I can see that the poor health, the mean value isn't. It's almost 1 portion away. And what we're finding out is that 1 portion makes a lot of difference to good health. Or certainly makes a big difference from bad health, poor health. Okay. So, I'm now going to have to come up with an idea on how to shift these values. So, let's look at some ideas. So, Fibonacci Sequence, which is an interesting biological feedback sequence, it basically takes the last number and adds it to the number that was previous to that to get a new number. And then you go through the sequence and you end up with this beautiful pattern. And it can be displayed in volume size, creating a shell, or it's a very beautiful and ornate pattern. And so I can use the way that that pattern was used, perhaps in my redistribution method. And then Newton came up with, didn't come up with the first one, it's older than him, but it was well written by Newton. And he had an interesting method of solving a square. Okay, and so in this we're going to try and, in this example, have a look somewhere else. Okay, so I've got my two methods. I've got my Fibonacci technique and complying it with solving the square technique, and I can see if I can create a portion. And what I can see is that my original starting point was 2.4, and then I can apply that, and I've shifted the mean portion down to 2. Okay, now I'm trying to get down lower than 2, so I just take the answers of the last one and I reapply that. But now my mean portion value has gone too low. It's now 1.6. And so what I need to do is find that kind of ratio between the 2 and the 1.6. And so what I can do is just find out that it's, and I'm trying to get to 1.85, and it's just 0.6 one way, 0.4 the other. And if I use a ratio of those first attempt and the second attempt, then I can get a new set of numbers which comes out with the correct mean value. Okay, and we can have a look. So I can see if I take the mean number of portions for the people that reported fair, I've got a very wide distribution from 0 to 8 portions. Lots of portions about the same, from basically from 2 portions to 5 portions. Lots of people eating that. It's a very stretched out curve. Now my first estimation, I've again got fairly stretched, but what we're noticing finally when I'm actually using the new recalculated method, I'm certainly seeing a peak at just over 1 portion, and then this dip down by 5 portions. Nobody's eating 5 portions in the fair health group. Now, if I apply those techniques on all the different categories, from excellent, good, fair and poor, then I'm starting to get a really interesting set of graphs. I'm starting to see that most people of poor health will only eat just under 1.5 portions. I'm seeing the mean number of the fair group will eat under 2 portions. And then I'm seeing the good health people, the majority of people, are eating about 2.8, which is what the other survey said, the National Nutrition Survey said. And I'm seeing children of excellent health are eating just more than half a portion, about 3/4 of a portion more than the children that felt good about their health, but still lower than the recommended 5. Okay, now in maths it's always good to be able to reverse a process, and so what we have to do is, what's interesting is to know, okay, if I can go down, what happens when I shift up? Now I actually use a very similar process, but in this I actually throw in a 1. It's kind of debatable whether that's the right thing to do or not, but it kind of helped on some of the maths, but also more on the way the algorithm stopped crashing out at 0 and having a division by 0. So what we can see is I can put the numbers in and I can reverse it and I can lift up the mean value. So let's just look at how that changes it. So I have the original value, I then lowered it from a 2.4 mean portion to a 1.8 mean portion, and then I returned it using reverse transformation, and I got it up to 2.43, very close. And what I can see is that the difference isn't too bad, considering I was able to change difference to a plus 13 or a minus 9 difference. Now it's most out by minus 4 to plus 3, so it has lost some information from the original, but it's not that badly out.